Today we'll be talking about soil physical properties. So these are the soil characteristics that you can feel or see. Things like the color, temperature, the solids in the soil. And then as we're going through this, we want to keep in mind um, the why physical properties are important. So how easily can roots grow? How well does the soil supply air, water, and nutrients to our plants? First, we'll revisit our ideal soil. Remember that we have about 50% pore space and 50% solids. Pore space is spread between water and air, and solids is spread between organic and mineral. So the particle size is important for the surface area of the particles. This varies greatly on particle size, and in a handful of soil, there can be thousands of square feet of internal surface area. Size is defined as the diameter of the particles. A lot of times in soil physics, we need to assume that our particles are perfect circles for some of our calculations. So, as we all know and can probably assume, that's not actually the case, and so that's where some interpretation of the numbers becomes important. Um, but it's sort of the basis we need to use for mathematical models. And then we use units of millimeters. Some coarse particles, so these would not be considered soil. These are larger than soil. But stones, cobbles, gravel, things like that, sort of a measurement range for you to keep in mind. And then we get into our soil particles. So a soil particle is anything less than 2 millimeters. And then we break it up into sand, silt, and clay based on these different measurements here. And then the organic matter is just thrown in there sort of as a reference as to how small that is, and so how huge the surface area can be of organic matter. So a lot of this comes from our parent material, if you remember our soil forming factors. So chlorped parent material. Sand is primarily quartz and feldspar, silt, quartz, feldspar, and mica, clay, mica, and other silicates and oxides. And then humus has a whole bunch of different composition changes. So texture is defined as the relative proportion of soil separates, so sand, silt, and clay in a soil. So texture is really important for porosity and internal surface area. It also becomes important for things like bulk density and a bunch of our other chemical and biological factors that we'll talk about in the future. So soil porosity, this is roughly, roughly relative, not to scale, just the difference between sand, silt, and the clay as far as particle size goes. So porosity is the total volume of soil pores and the distribution of pore sizes. So we can see, in this case, the pores would be the space in between the particles. So in sand, we have quite large pores for large particles, and in clay, we have quite small pores with small particles. These are some pictures of magnified sand, and so again, you can see those large pore spaces formed in there. And then this also brings up our assumption that our particles are circular. Obviously, that's not the case if this is what magnifying sand looks like. So the size of soil particles, again, soil separates are anything 2 millimeters and smaller. So sand is from 0.5 to 2 millimeters. Silt is 0.002 to 0.05 millimeters. And clay is less than 0.002 millimeters. And this is a chart from the International Society of Soil Science and the USDA, and then U.S. Public Roads Administration. So 3 different ways to classify those soil particles. In soil science, it's clay, silt, and sand. They have fine and coarse. In USDA, they break sand down a lot more from very fine, fine, medium, coarse, very coarse. And then From the road side of things, this would be for like engineering calculations. They go back to the fine coarse, but have slightly different um, particle diameters. So we will stick to the International Society of Soil Science definitions up here. And on the right, again, just sort of a general, more to scale relation between sand. So this large particle here is coarse sand. Down here we have fine sand, so quite a range in our sands. And then we have silt and then clay. So you can see how much smaller clay is compared to our coarse sand. Large particles yield large pores, small particles yield small pores, like we mentioned earlier. So water can move rapidly through coarse textured sandy soils, and sandy soils don't hold on to that moisture very well because it can move so quickly. Opposite is true for our finer textured loams and especially our clay soils, where water can move slowly and is retained onto the surface of those soil particles. So this kind of breaks up again the difference in surface area. So the same cubes, when broken up into smaller particles, we see that there's sort of an exponential increase in surface area. So the surface area is 16 times larger on the right when we break all those cubes down than it is on the left when it's one large particle. So surface area, specific surface area, is the surface area divided by the mass in squared centimeters per gram. And this becomes really important when we talk about soil's roles and how it interfaces. So that soil particle is holding on to water, nutrients, and pore space for gases and water. Microorganisms thrive in those pore spaces that are also filled with organic matter. So sand, silt, and clay, rough specific surface areas. Again, clay, exponentially higher surface area. In a soccer stadium size, surface area is equal to 16 grams of clay. So 16 grams of clay has as much surface area as an entire soccer field, all rolled up into less than a handful of soil. To put it another way, we'll compare two soils, soil A, soil B. Take a 100-gram sample of each soil. Only difference is soil B has 50 fewer grams of sand, or 5 fewer grams of sand, and 5 more grams of clay. So just that change of 5 grams. We do some quick calculations here, and we see that there's nearly 6 times the surface area in soil B just because of that 5 grams change from sand to clay. And so that's a really good illustration to the importance of knowing your soil texture and how it can affect your management. And we will do soil texture classes in the next video. Thanks.